Hey, everybody, it's Mr. Paul, and welcome to your last chapter of the semester. We are going to be going into chapter 12, but before we do that, you guys can see that I'm looking at some chapter 11 stuff. I still don't have everyone turning in their homework packets, or have finished or have taken the quizzes yet for chapter 11. So please make sure that you guys get on that and get that done. Like I said, we are going to be moving on to the last chapter here for geometry, chapter 12. I put in some of the notes, but I'm still in the process of deciding what I want to make for homework. We're going to follow the same format, and we're going to go with homework, homework Monday, Wednesday this week, and then Monday of next week, and then there'll be another quiz after that, and that should be your last quiz for chapter 12 and for geometry. So, like I said, you'll have to take a look and come back to that when I have kind of decided what that's going to look like, what we're going to do there. So, for the notes today, your guided notes, you guys are going to be working on 12.1. And this section has to do with what's called sample space and kind of what's the fundamental counting principle. And it'll be pretty simple too as well. I'm going to use the whiteboard app. So if you guys want to download the file or open it up with your whiteboard, that's great. Or you guys can copy them down on your own, or you can print them out if you'd like as well. Now I am going to try to use some cursive writing because I know that helps with the sounds that are going on too. So bear with me in that. I'm working on that. All right. So anyways, what is a sample space? That's what we're going to start out with here. And a sample space is, let's try that again. Okay, a sample space is the set of all possible outcomes. All right. So how's that going to look? Well, that can be it can be represented by a list, table, and a tree diagram. All right. Yeah, my cursive is usually a lot better than this, but it's a little bit difficult writing on my screen while it's standing slanted. All right, so let's move on then. Write a sample space for each scenario, then write the number of possible outcomes. So here's our example. A sandwich shop offers meals where you must pick a sandwich, chips, and a drink. Okay, your choices for the sandwiches are, what do we got here? We've got turkey, we've got tuna salad, and we've got veggies. And then our choices for our chips are Cheetos or Cool Ranch Doritos. And for our drinks, we've got Coke, Diet Coke, Sprite, and iced tea. Okay, I'm going to show you guys an example or one way of kind of writing this out. It doesn't have to be the only way, but it can be a way. Maybe you guys have a different way, and that's going to be fine as well. And here we go. Let's say that we're going to separate this into turkey, tuna salad, and what do we have? The last one, veggie. All right, from there, you have your choices of chips. So for chips, we're either looking at Cheetos or Cool Ranch Doritos. Um, and what's that on? Let's go open right here. Cheetos or Cool Ranch. All right, and then we're going to do the same thing for the other one. We've got Cheetos or Cool Ranch. Cheetos. And I'm running out of room, so we're going to go CR for Cool Ranch. All right, so turkey, we've got a choice of Cheetos or Cool Ranch. For tuna, we've got a choice of Cheetos or Cool Ranch, and the same thing for a veggie sandwich. All right, from there, we're going to take our last choice, and that has to do with our drink selection. So remember, for drinks, we've got Coke, Diet Coke, Sprite, or iced tea. There's a lot of them, so I'm going to use my abbreviations. We're going to go with C for Coke, DC for Diet Coke, S for Sprite, or IT for iced tea. All right, got Coke, Diet Coke, Sprite, iced tea, Coke, Diet Coke, Sprite, iced tea. And nope. I need to go back. Okay. Now, problem was that I was doing that as if that was the choice for, you only had 4 choices for Cheetos and Cool Ranch, but you have 4 choices if you choose Cheetos as a sandwich. So that means you've got Coke, Diet Coke, Sprite, and iced tea. But you have the same thing if you chose Cool Ranch Doritos as your chips as well. So think about it like a combo meal. And, what kind of choices do you get from here? Coke, Diet Coke, Sprite, iced tea. 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 All right, so getting a little bit filled in here. And let's see. There we go. Took it a while. All right, so let's count up our choices here. We got Coke, Diet Coke, Sprite, or iced tea. All right, so what we're looking for is how many combinations do we have here at the end? And if we count them up, there should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. All right, so there's our solution right there. So there are 24 different combos. Right? That's example 1. Example 2 says, if a coin is flipped 3 times. So we're going to separate this, and let's think about this. And we've got our first flip, our second flip, and our third flip. And when you flip it, first thing, you either can have 2 choices. It either is going to land heads or it's going to land tails. From there, your second choice, it could either land heads or tails again. Heads or tails. And then from those choices, when you're flipping the third time, understand that the third flip could also be heads or tails, heads or tails, heads or tails, or heads or tails. Okay, so each time you're flipping the coin, there's only 2 possible choices. It's either going to be heads or it's going to be tails. You had 2 choices here. There were 2 choices when you flip that coin the second time, and you've got 2 choices again when you flip it for the third time. All right, now if I took these numbers and I multiplied them together, okay, well, what am I going to get? What's 2 times 2 times 2? Oh, that equals 8, which is the same thing as 2 to the third power. Well, let's count this out. What do I get here? 1, 2, 3, 4, 5, 6, 7, 8. There are 8 outcomes. Okay, so again, more than one way to come to the solution here. All right, moving along. What is the fundamental counting principle? We're going to use this, and hoping I can fit this in here. So the fundamental counting principle, the number of possible outcomes All right, the number of possible outcomes can be found by multiplying the number of possible outcomes from each stage or event. So if you think about it from the previous example, what did I do? Well, there's 2 possible outcomes from the first flip. Then there's 2 from the second flip, and there's 2 possible outcomes from the third flip. So if I multiply each of those together, then I end up with my solution, okay, or my number of outcomes. So that's saying whatever your first number is, however many possible outcomes you can get, you multiply that times the second one, then you multiply that times the third one, and then you're going to multiply that times, you're going to keep going till however many possible times you're doing it or events you're looking at or that kind of thing. So let's use, again, fundamental counting principles to find the number of outcomes for each scenario. So if a coin is flipped 8 times, so instead of writing this out like I did in example 2, now we're just going to use this FCP principle to come to our solution here. So if I said that, all right, well, we know a coin has 2 possible outcomes, heads or tails. And we're going to do that 8 times. So there's 1, 2, 3, 4, 5, 6, 7, 8. Okay. Well, that's the same thing as saying 2 to the 8th power. And 2 to the 8th power is, okay, calculators, boom, 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 boom. 256. All right, so, well, what if you're not flipping a coin? What if it's something other than that? What if there's more than 2 possible outcomes? All right, well, let's take a look at that. You open your closet and discover you only have 2 clean pairs of pants, 4 clean shirts, and 3 pairs of shoes. How many outfits are possible if you select one of each of them? All right, so what we're going to do is think about this. If you have pants, we've got shirts, and we've got shoes. How many from each of them? Pants, what do I've got? I've got 2 of them. Shirts, how many are clean? There's 4 of them. Shoes, we got 3 of them. And if we multiply those all together, we get 24. 4 times 2 is 8. 8 times 3 is 24. So there are 24 different outfits that you could wear. Okay. All right, we're going to keep moving along. I'm trying to keep the time down for you guys, so let's keep going. Let's go to the next page. Oh, well, this is coming up. Don't forget, today is May 4th. So all of you Star Wars fans out there, may the 4th be with you. And hopefully you guys, nerd out a little bit today. Besides doing your homework, maybe watch some Star Wars. I am curious if you guys have been getting the notes. If you guys have had any problems with them, please, feel free to let me know. I've been trying to get better as the month went along, and so hopefully things are starting to smooth out a little bit. Working on making sure that you guys are able to get everything you can from the lessons, and that way you guys seem to be doing a lot better on the quizzes that you guys are taking. So good job with that. All right, example 5. You're creating a 4-digit lock combination using the numbers 0 through 9. How many different combinations are possible? So think about this. You're using the numbers 0 through 9. So how many different numbers are there? That's not 9. That's 10. 10 different numbers. So if that's one of the 4, okay, it's a 4-digit lock combination. So there's 1. Well, the next one has 10 possible choices. The next digit has 10 possible choices. And then the third one has 10 possible choices as well. And so if I multiply all that together, we end up with 10,000. All right. How many different choices are possible if the first digit cannot be 0 or 1? Okay. All right, 0 or 1. So if I take 0, 1 away from there, that means I'm taking 2 different choices away out of the 10 from the first one. So instead of it being 10, now it's 8. But the second choice, you can still use the numbers 0 through 9. So that means there's 10 choices there. The third one still uses the numbers 0 through 9. So there's 10 choices there. And then the fourth one also uses 0 through 9, 10 choices there. So you're multiplying these 4 numbers together. And what do we got? 80 times 10 times 10. 8,000. Different combinations are possible. Well, so hope you don't forget. You can be there for a while trying guessing checking. All right, how many different combinations are possible if each digit may only be used once? Okay, and probably this is often described as without repetition. So no repetition. And we're looking at, let's separate these again as far as the first, second, third, and fourth. All right, so the first one, we can use 10. Okay, it's got 0 through 9. The next one, whatever number we used in the first one, we can't use in the second one. So now there's only 9 possible choices. All right, and the third one, we can't use the number from the first digit, from the second digit. So now there are 8 possible choices. And if you couldn't tell, for the fourth one, there's only going to be 7 possible choices. All right, so we multiply these 4 numbers together, and we end up with 5,040 possible choices. All right, guys getting that? Well, that's coming back up. Let's move on. Let's go to example 6. The Kentucky Derby is this Saturday and features 20 of the fastest horses in the world. How many ways can the horses place in the race? All right, so Kentucky Derby. Well, let's think about this. You've got what? First place. Just trying to move this over. And it is not going as planned. So let's try that again. All right. Kind of running out of time here, so I'm going to try to get through this, even though there's a little bit of difficulty with the screen. All right, the Kentucky Derby. All right, this Saturday, what do we got? Well, we got the first horse. We've also got the second horse, the third horse. Okay, and we can say, oh, all the other ones until you get down to the last horse. So what's that going to look like? Well, it says that there's 20 horses in this race. Okay, if there's 20 horses in the race, that means that for first place, there's 20 different options. But for second place, there's only 19. For third place, there's only 18. Okay. And you guys can see that there is this pattern going on. Boom, boom, boom. Which means for the last place, there's only one horse left. That can be the last place. So if we took these numbers and multiplied them all together, okay, this is another way of saying what's called 20 factorial. 20 times 19 times 18 times 17, 16, 15, 14, 13, 12, 11, 10, 9. Keep going all the way down. Well, you're going to end up with quite a large number. 2.4329 times, we're going scientific notation here, 10 to the 18th power. All right, I know you guys go to figure that out on your calculator, but I was just going to give it to you anyways. So understand that that's quite a lot of different choices here. Let's see. Number 7. This is the last one I'll be able to get to because we're running out of time here. Have you ever noticed that in California, most cars have license plates with a pattern of one number followed by 3 letters followed by 3 numbers? How many possible California car license plates are there? All right, so if we were going to separate this, what we've got number, then we've got letters, and then we've got 3 numbers. Number, letters, 3 letters, and then 3 numbers. Well, the numbers, again, have the same, what we've been going through here, 0 through 9. So if we're going through 0 through 9, that means there are 10 possibilities here. The letters, if you don't know, there's 26 letters in the alphabet, but there's 3 of them. And they could be the same letter. It doesn't matter. So it's got 26 choices each time. And then there's 3 numbers at the end. 10 times 10 times 10. All right, you guys take those numbers, multiply them together, and see if you can figure out what that answer is. And then why don't you guys go ahead and do example 8 too as well. If you have questions, please feel free to email me or come by during my office hours. You guys know that the link is there on the haiku page. Yeah, other than that, it's should tie in pretty nicely to the homework. And then, like I said, this is the last chapter. So finish off strong, and I will see you guys later. All right, take care. Bye.